In this video, we're going to talk about the idea of differential equations. It's actually a concept that we've used already in this class, however we haven't named it differential equations. And a differential equation is simply an equation that has a derivative in it. And we also define the order of a differential equation as the order of the highest derivative involved in the equation. So if we have an equation with the second derivative, then it would be order 2. If we had an equation with the fourth derivative, it would be of the order 4. Here are some examples of differential equations. This equation right here should look familiar to us, and it simply says that the derivative of y with respect to x is 3x squared, and we could solve this differential equation and say that y is equal to x cubed or x cubed plus some constant, because when we take the derivative of that constant, the constant's going to disappear. We also see here in this example we have a second derivative is equal to 3x squared, and we know how to work with that to some extent. We can figure out what the first derivative is going to equal plus some constant, and then use that to figure out what the function is. But we also have some differential equations here where the derivative depends on x and y. So we have here a function of x and y for our derivative, which tells us that the slope not only depends on the x value, but it also depends on the y value at any particular point. And so we have a differential equation like that here and here. Here we have a differential equation that only depends on y. This one in particular is interesting because the solution to this is essentially a sine curve. And then here we have one where it has two different derivatives. It has a second derivative and a first derivative. So this would be a second order differential equation because it has a second derivative in it. We will be working with differential equations in a lot of ways. We'll be looking at how we could solve differential equations and use something like this or something like this to look at what a function might look like with that derivative.